Alright, I resharpened my bit, so now I'm going to recut the surface here. I'll move it kind of jiggle around. I should be within 5, I think. So I'm going to do a slight skim cut on this one and go on the other side and see what we got to deal with. Okay, and this is now sharp again, hopefully. Find out in a minute. I didn't reset this to 0 yet, so we'll go until we hit. Yeah, we're just getting right there. That way. Down about 3. There's the cut mark we're looking for. Okay. We got our nick right there, so I don't really cut much, but okay, that was a fairly heavy cut. Okay. So we're back at 80. So we're gonna have to go and see what we did on the other side. First thing, go back to our 0. It's right there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Come back to 0 to square everything up. So we're at 70. That's at 90. I don't want that. No, we're going to be at 0. That's right. Okay, so we're at 75 right now. So, all right, we should be clear to go this way now. Looking good. Oh, yeah, that nailed me. Don't stand too close to your power tools. Get in trouble. Okay. Alright, what I'm just going to do is put this down. Okay, we're at 0. Spin this around. And we were cutting pretty heavy there. Okay, we're not cutting at 5. I don't know if that's really going to be enough, because that doesn't. Nope, we are just touching perfect. So I need to clean 5 because it's uneven, so it's right where I want to be. Alright, looks like we got it right on the money. Okay, I gotta go here. This thing over here so I can cut the back of the case here, clearance. Get some clearance here. Okay. Boom, boom, boom. Okay. Put that on and go until we touch. See, we touched right there. 477 now. cut there. Oh yeah. In the original case, what do we got here? Not even touching. Not yet anyway. Yeah, we didn't even touch. Why are we not touching? Oh, that's because we cut the case at a different angle before. Okay, so that's going to be cutting even deeper. We're going to move it in some more until we hit. Where are we at? No, we're going to 0, that's right. Okay, we're just touching right there. That leaves 5 to go. So we're going to feed this in until we touch. We'll touch. Oh yeah, we're good. 473 right there. Okay, that'll leave 2 for finish. Just square up this surface, hopefully. Yeah, I can see it cleaning. See the cut line there? Okay. Back to 0. Until we almost touch. Okay, there's 0, and we go all the way to 30 plus. How much I can push it? 30 plus. Bring it to 0. Put it in my 580 offset. Contact. Thou pass. Cutter's getting broken in, we'll do a little better pattern now. Takes a couple passes to break the cutter in. Like everything needs to be broken in. Okay, don't get near that thing, it'll hurt you. Okay. So nice and flat, cut full depth. Yep. When I sharpen this, I cut a lot of angle out of it because it chipped the hole into it pretty bad. So right now we're a little bit too much flat. So the cutter is actually hitting way up here where it's not supposed to on the aluminum. So the seal's cutting the aluminum, not the carbide cutter. So that's why it doesn't cut very good. I'll have to resharpen that some more. Oh well. This side here would clean up pretty nice. Alright, so there's our 580 offset. 1.580. Go back to 0 here. And we go 15.8, 15 turns plus 8 more, 80 thou more, not 8 turns more. Get you what you want. Okay, so now, let's see what we got here. I need to get back in here to check some offsets. So let's get this thing out of my way. Right there. Get that out of the way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Get that out of my way. Alright. Should give me enough where I can get in here. Tripod out of here. Nobody likes that stupid tripod. I don't like it. Get rid of my noise maker back here. Best phase converter on the market right there. Okay, there is on. Should be 1/10 of a degree off. So it's going to be a 90. We're 90 or 89.9. We get to 89.9 or 89.8 now. That's 8, 89.8. $89.9, it's right on the verge of 9 and 8, so it's right there at 9. Okay. Well, we were off 2/10 this way, or 3/10, so that should be 0 now. I'm going to put my plate on there and check that though. Okay, this side should be pretty damn close to 0. Let's check my tooling. Is that 2/10? Where's my number at? There we go. 2.02 off. That's because I'm holding only one little corner. It's pretty close. Okay, let's go check our decks here. We're basically running a 1/10 of a degree of tilt. 22.2 now, 22.3. That's 2/10 of a degree of tilt. And I wait long enough, it might go to a 4, but I don't feel like waiting any longer. And this deck surface is still not dead flat yet, so we're still got some air built into this. This one's 22.5. It should actually be a little bit higher than that. It should be 6 at least. So it's at 22.5 where it belongs. And these, let's see, we're at 22.3 before. What are we at now? I can't read it. 22.2 is what I got. We were at 22.3 before. And this one, hold the square, 22.4. So we went to 10th the other way because it was 22.3. I think were the numbers before. Okay, so the only thing I'm curious about right now is how accurate is my clamping device for that. If you have a flat surface, does it actually measure the same as what it's supposed to be? So let's find out. We're going to put our little plate back on there and do a little tool test. We had 0.02 off over there, remember? If everything's perfect, this should be the same number. I'd be shocked if it is, because I think this induces a little bit of error. When you only clamp on a thin surface on one side, it's going to pull it. It's just a matter of how much. Okay, something good flat. I'm not exactly center, but it overhangs the lip, so it doesn't matter. Okay. Tool test. It induces a lot. There's our 2/10 back. We know it's cut square. (2.4). So that's what it was when I started. But this wasn't flat when I started. It did actually cut quite a bit on its outside edge, so this is not a good test for clamping to. We're getting an error, quite a bit of an error. Three-tenths, one-tenth, or not tenth, 1/100th. What, no zero? Yeah, it's 0.01. So that's how flat the mill table is to earth. Not the floor, earth. We don't know what the floor is. Okay. So this here is definitely inducing an error, which doesn't surprise me, but I was hoping to be better than 2/10 out. That's pretty bad, actually. Yeah, 2/10, 2.5 tenths, 2.5. So how much of that is the tool, how much of that's the clamping? So now you take this out, you flip it over 180, measure it again, because this might have a bow in it, you don't know. It shouldn't have any bow in it, but it doesn't mean it doesn't have it. Same side, same offset. I'm tightening it with the bolt, not the nut, because I don't want the nut to turn on it. I'm going to put about 5 foot-pounds on there at most. I feel like I'm clamping the piss out of it. Okay, now, see there's a little bit of a bow in the plate because we're now a 1/10 of a degree better. We were at 24.5, now we're at 14. Okay, so that means this has a little bit of a bow in it too. So it's not real secure. Let it center a little bit. That helped it a lot. Jiggle around, let it find its true center. 0.03, that's pretty nice. Okay, let me flip it over and check the other way. So, got to learn how to use your tools. So don't just clamp it. Give it a little wiggle after you clamp it. To let things kind of self-center, I guess. Well, you can definitely feel it moving around when you do that. I can feel it push down and hit on a hard stop. Oh, that's way better now. Okay, so yep, it was better until it went back to bad. All right. Now this side seems to be repeating, so that tells me this parallel is not the flattest thing in the world, I guess. So even though I thought that was a flat tool, it obviously is not very flat because it's out of whack 3/10 now. You can definitely feel a hard stop on here though. All right, so the tooling is not the best. I didn't think it'd be all that accurate, but I didn't think it'd be off by that much. So let's turn it 180 and see what happens this way. It's the same side. You can definitely feel a hard stop when you push on it. That one's 15 right now. This side appears to be a little bit better than this side here. And 18 there. Yep, 18. Alright, so we're not getting a very accurate reading come off here. Now, can I do a better job by holding it? We know it should be 0 because we just cut it. Well, it's going to be 0 wherever the table is, and the table's off by 0.01. Pretty close to 0. Okay, so now, can I feel what I want to feel for the high, low, for where it's all the way it belongs? Okay, there's where it should be. Like 1.1 or so. I don't know if you can see it on the screen, but yeah, it's 07 to 10. So I can hold it better than that plate does, but I'm literally working on no holding power. So you go until you hit, and you go down until you can feel the surface hit. I'm not looking at the number, I'm just using feel right now. Something about an air feels about where it belongs. You can see we're at 12, 1, 12. But yeah, there's not much to work to. So I'm about 12 to 14 out by holding it by hand. Like I said, you're only using this outer triangle. You got nothing to hold in with. And even this looks like it's worn. Yeah, it's from here over, it's radiused off, so half of what I was holding off was wasn't even touching. I'm literally only working on just a little 1/16 of an inch area. It's pretty bad. Now this side over here is not worn so bad. See, this has been used a lot. This side over here, you still got very little feel. Yeah. It's really, really hard to go by something that narrow of a holding power. Just doesn't have no accuracy to it. Okay, so over here we were a lot better. All right, well, there you go. I got the amounts cut. We're at our 1.580 the customer wanted. So that would be, let's see, 580. You're coming down from 990. So that's 410 thou offset, which is halfway. It's closer to 7/16 offset than 3/8, but it's like 2/3 of the way up to 7/16. So 7/16 is right here. Stand back a little bit. Whoa, banging all kind of stuff behind me. 437 is 7/16. 3/8 is way over here. 410 is, it's almost in the middle. 410-ish, 413. Yeah, it's kind of right in the middle between the two. So there you go. Yeah, that's what they say it's supposed to be, but V-twin, they say 5/16 is way up here. So his frame's down here. It's 100 thou difference in what V-twin would say their frame is. So he has less offset. So if his frame is bent up a little bit in the front, that'll give you that kind of a number. But I don't know. It's more important to know that the motor bolts in the frame correctly than it is what the number actually is. So he measures offset at that number, so that's what we put it at. Okay, I'm going to flip this around and go look at the decks.